Hello guys. As everyone finished the homework 6 or project 2, let's have a briefly discussion. For the rotate, if you remember the origin code are just these 3 lines, right? But what's the key point for rotate? As you may find it from the instruction, there are so many memory access because it need to fetch the memory, to fetch different data from different blocks. So it's more like a memory sensitive, but for the smooth, it just need to calculate. You want to smooth a pixel with its neighbors, right? So it just need to be more computative instead of want to fetch from more memories. So these are 2 key points between these 2 tasks. So let's go for the rotate first. You can see it firstly do the J and then do the I. As you may remember, for a memory block, we may say left side will be the I, right? And the row will be the I, the column will be the J. So if you fetch J and then fetch I, it will kind of like, okay, I will fetch the first column and then I will go for first column, go to the first row, right? But so you may find it, okay, I will get this, and then I will get this. But you will, but memory, for our memory block, it's a cache line or a block or block line is a line by line instead of a column by column. So how about if I fetch I and then fetch J? I can directly fetch a whole row and then go to the next row, right? My memory can simply fetch by a continue space instead of, okay, I will split the first row into the first column and then I fetch the second. I hope I can explain it clearly, but that's how, because memory is a line, but you are fetching by a column and then by the line. So that's not a good idea for our memory fetching, but let's go for any other methods. You may find that so you can see there are 2 for loops. Maybe we will try to do unrolling, right? Unrolling, so is it unrolling make sense? Yeah, sure, because as we want to fetch so many data from a memory, if we can unroll, then I can fetch maybe fetch one data, one line, and then fetch another line. Unroll can help you fetch more cache lines from a memory. More memory lines. So it can help your memory fetching in the same loop, in the same cycle, right? So loop unrolling is the key point for our rotate work. So you may think about, so how many loops should I unroll? Should it be 4, 8, or 16, 32? So I would recommend for 32 because our image is 32 base, right? We are 5, 12, and 10, 24, so on and so on. So they are all 32 base. So why not we fetch 32, right? It can save us more time. And then you may think about blocking, memory blocking. Sure, memory blocking also works. And then the loop interchange, as we mentioned, change the I and J loop. And the code motion, yeah, sure. When you want to represent something like the source and direction, right? When you want to calculate, you can pre-calculate some source, I think, or maybe the directions. It also work, but the biggest improvement is the loop unrolling. You can also try the memory blocking with the loop unrolling. It can save you so many times or cycles, right? Are there any I want to say? Yeah, there are some performance I tried. So, and why the Markov substitution doesn't work too much? Because it's a language of coding things. It's not a code improvement things. I mean, it could not help the code to, it could not help the machine to say, okay, let's run faster. It just use another language. All right. Yeah. And yeah, there is the unrolling. Yeah. And then we go to the smooth. For the smooth, we also can see that okay, do the J and then the I. It means I fetch the column and then fetch the row. But since it's a compute sensitive, so it doesn't have too much matters. So you can do the loop interchange or not, and that's both okay. But the most important is that we have a predefined average function. For each loop, you will call the function time by time, right? The average function will just do the sum of the and then calculate the average. So there are so many calculations which yeah, takes so many compute source. And as you can see that there are 3 pixels, but each one have 3 channels RGB, right? 3 colors. So what you want to do there must be the function inlining. You don't want to call this average function time by time. So let's make this function more specific, or split it into like how to handle the edge, how to handle the corner, and how to handle the middle part of the image. So the key point is to do the function inlining. And yeah, the loop interchange you can do or not, they're both okay because it doesn't have too much but yeah, because it's calculating things. And yeah, another calculator is common subexpressions eliminator. That's the pre-compute things. And code motion also just to move some common calculations. Yeah. And strength in reduction, yeah, actually they are all do nearly the same thing, but the loop unrolling and the memory blocking doesn't help too much, I think, because it's compute sensitive. So even though you want to fetch something from memory, it doesn't help too much for this calculation, right? So yeah, use the function inlining and the loop interchange with some other methods. We can achieve like 6 to 7 speed up. That is the quick review for the homework 6 of project 2.